Hi everybody, welcome to my talk about Postgres deployment automation with Terraform and Ansible. In this talk, we will cover a quick introduction to Ansible and Terraform. We will see how EDB addresses Postgres deployment automation needs through two new open source projects based on Ansible and Terraform. We will have a tour of the available features and finally a quick overview of the features we have planned to add. Let me start with a few words about me. My name is Julien Tachoir. I'm from France. I am a Postgres performance engineer at EDB. I have more than 10 years of experience with Postgres. I started with the 8.4 version. I am the original author of open source tools around Postgres, such as Pgactivity and Temboard. And I have more than 6 years of experience with providing Postgres deployment automation and management tools for French big companies. My main mission was to help those companies to go with Postgres from zero to production. About Ansible and Terraform. Ansible is a technology to automate applications and configure infrastructure. There are 4 levels of abstraction for configuration. The first one is a task level, which are the single action. We have the task list level, which is a list of actions. We have the role level, which is a list of actions grouped by the same subject. This is a way to group tasks together into one container. And finally, the playbook level, which is a list of plays applying several roles, tasks, or task lists. Collection is a distribution format for Ansible content that can include playbooks, role, modules, and plugins. Ansible Galaxy is an online platform where users can share roles and collection. And the Ansible Galaxy tool is used to download the desired roles and collections. About Terraform. Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. Terraform can manage existing and popular service providers as well as custom in-house solutions. Configuration files describe to Terraform the components needed to run a single application or your entire data center. Terraform generates an execution plan describing what it will do to reach the desired state and then execute it to build the described infrastructure. Let's talk about Postgres deployment automation with Ansible. So the first open source project I would like to introduce is EDB Postgres. EDB Postgres is an Ansible collection of roles implementing multiple features that will help day-to-day operations. This project is open source and released under a BSD license. Source code repository is hosted on GitHub. The releases are available on the Ansible Galaxy platform. This collection helps users to deploy a reference Postgres architecture with a single command line. The operating systems supported on target instances are CentOS and Red Hat Linux in version 7 and 8. It supports 2 types of database engines, which are Postgres and the EDB Postgres Advanced Server. The main capabilities and features have been split into several Ansible roles. So with this collection, we can configure the access to RPM repositories, including EPL, PGDG, and EDB repo. This selection of repository will depend on the component we want to deploy. With this collection, we can also install the database server packages. We can initialize database instances. We can set up streaming replication. We can also set up a Postgres Enterprise Manager server and deploy the agent on the database machines. We can set up automatic failover with Enterprise DB Failover Manager. We can execute several administration tasks on the database's instances like user creation, configuration management, and so on. And finally, we have recently added native connection pooler deployment and management roles. So with EDB Postgres, we can deploy PgBouncer or Pgpoolll 2 instances. A few words about the installation procedure. So the last EDB Postgres collection version can be installed through the Ansible Galaxy tool. Or if you want to try the very new features, you can just clone the GitHub repository. The main key feature of this Ansible collection is the capability to deploy your reference architecture with a single command line. This implies to have a working Ansible environment and the Ansible playbook command available. In this example, our command line argument is playbook.yml. This is the path to our deployment description file. It can be a list of files, but in our case, we will only need one file. The U option set the target username to use for SSH connection, and we can also set a specific SSH key to use. The playbook.yml file is our deployment description file. In this file, we have to define some variables to match our needs. The OS variable set the operating system we have on the target machines. The PG version variable is a Postgres major version we want to deploy. The PG type variable is a database engine type we want to deploy. It could be ePath for EDB Postgres Advanced Server or PG for PostgreSQL. Yum username and Yum password variables set the credential for accessing EDB RPM repository. The playbook.yml file references another YAML file, which is the hosts.yml file. The hosts.yml file will define the list of the machines on which we want to deploy the components. For each machine, we have some attributes defining the characteristic of the nodes. For example, we can configure the type of the service we want to deploy with the node type attribute. The value could be primary for a read-write Postgres instance or standby for a streaming replicated standby, for example. Here we have an example of a single node deployment configuration. Only one server is referenced and its node type is set to primary. In this example, we want to deploy Postgres on 3 machines. The node 1 machine will host our Postgres primary instance, and the node 2 machine will host a synchronous streaming replication instance of node 1. And the node 3 machine will host an asynchronous streaming replication instance of node 1. Sorry. So far we have seen how to deploy Postgres with the EDB Postgres Ansible collection, but there are many other features, especially in the managed DB server role. The managed DB server role can be used to manage the database users. With the variable PG users, we can define the users and their attributes we want to be present or the user we want to remove. With the variable PG grant role, we can define the Postgres role we want to grant to users. And with the PG ground privileges variable, we can define the ground privileges we want to apply. The manage DB server role can also be used to manage configurations and databases. Postgres configuration parameters can be changed through the PG Postgres conf params variable. With the PG IP addresses, we can manage PG IP entries. Databases and extension creation can be achieved using the PG databases and PG extension variables. Physical and logical replication slots can be managed through the PG slots variable. With the help of the manage DB server role, we are also able to execute a single SQL query on the database with the PG query variable. We can copy local SQL script files on the target machine and execute them with the pgcopy file and pgsql script variables. Finally, we can manage pgpass file entries with the pgpass values variable. So let's take a look at some brand new features we have added in the last month. The EDB Postgres collection brings now Postgres connection puller capabilities. About Pgbouncer, Pgbouncer is an open source lightweight connection puller for Postgres. Due to its low footprint, Pgbouncer instance can be installed on the Postgres nodes or on a dedicated host. Pgbouncer setup will be done by the setup Pgbouncer role. User and database list can be managed through the manage Pgbouncer role. About the deployment, for dedicated node deployment, we have to add a new server entry in the hosts.yml file and set the node type to pgbouncer. But when we want to deploy a pgbouncer instance next to a Postgres instance, we just have to add the attribute pgbouncer and set it to true if the corresponding in the corresponding server entry. So we have those two deployment model variables. This is a playbook example for setting up Pgbouncer instances. Some of the Pgbouncer configuration parameters are available through user variables. In this snippet, we configure Pgbouncer listening port to 6432, the listening addresses to all, the default pool size to 20, the maximum number of client connection allowed to 100. We raise the limit of the open file descriptor to 2048, and we set the pooling mode to transaction. For setting up access to RPM repositories, we include the setup repo role, and finally we include the setup pgbouncer role. This role is in charge of the package installation, creation of the working directories, opening the listening port, and generate configuration and systemd files. Well, the manage pgbouncer role can be used to manage the user list and the pool list. So with the variable pgbouncer or user list, we can define the users and their password we want to be here, or the users we want to remove. With the pgbouncer databases list, we handle our pool list. So for each connection pool, we can define the target database name, the public IP of the target Postgres instance, the Postgres port, the pool size, the pool mode, etc. Sorry. So Pgpool2 is another popular connection pooling tool, but unlike Pgbouncer, Pgpoolll has a significant footprint on the system. That's why the setup Pgpool2 role allows its deployment only on a dedicated node. Users and configuration management are done by the manage Pgpool2 role. Pgpool has many very interesting features, and some of them can be enabled by the setup Pgpool2 roles. The first interesting feature is the high availability of Pgpool instances themselves. In this case, we need a odd number of Pgpool nodes, at least 3 nodes. One of the nodes will be the primary, and the others are the standbys. In this configuration, it's recommended to attribute a virtual IP address to the Pgpool cluster. Then this virtual IP address will be set up on the primary Pgpool node. All the client application must be configured to connect to this virtual IP address. So when the Pgpool primary node fails for any reason, the failover occurs and the virtual IP address is moved on the new primary Pgpool node. Another interesting feature is that Pgpool can balance read-only queries across the Postgres nodes. This is useful when for read scaling when we have several Postgres standby nodes. And another interesting feature is that Pgpool can be configured to detect automatically which of the Postgres node is a primary one. So this is useful for routing write queries to the new primary Postgres node when Postgres failover occurs in a streaming replication context. So all this feature can be enabled by the setup Pgpool2 role. So in this example, we want to deploy a single node Pgpool instance. We have only one server item in the hosts.yml file, and its node type attribute is set up to Pgpool2. As you can see, we can set Pgpool configuration parameters through the Pgpool2 configuration variable. For setting up access to RPM repositories, we include the setup repo role. And finally, we include the setup Pgpool2 role. This role is in charge of the package installation, the creation of the working directory, opening the listening ports, and generate configuration and systemd files. Let's continue with a more complex deployment example. In this example, we want to deploy a multi-nodes Pgpool cluster composed by the machines Pooll1, Pooll2, and Pooll3. We want to enable the high availability capability for this Pgpool cluster. So we need to set the Pgpool2 watchdog variable to true. We want to have a unique connection endpoint for our applications. So we can set up a virtual IP address for the Pgpool primary node. When using virtual IP address, you must define the network device on which the virtual IP address will be put on. Now we want to enable reads load balancing across the Postgres node. So the variable Pgpool2 load balancing must be set to true. And finally, we can define a specific Postgres users that will be used by Pgpool to check Postgres node's role. In this case, we don't have to set the password, so these passwords will be generated automatically. About the manage Pgpool2 role. So this role can be used to manage the user list and the configuration parameters. So with the Pgpool2 users variable, we can define the users and their password we want to be here or we want to remove. With the Pgpoolll configuration variable, we manage the configuration parameters changes we want to apply on the Pgpoolll configuration file. Um, the key attribute refers to the configuration parameter name. The value attribute is its value itself. The strings values must be quoted in the Pgpoolll configuration file. So that's why we have the attribute quoted to define if the parameter must if the parameter value must be quoted or not. And the state attribute defines if the parameter should be present or absent. So far, we have seen how to automate the deployment of Postgres architecture with Ansible. This approach requires the machines to be already available and the SSH connection working. To address this machine provisioning need in public cloud context, Edb is creating a new command line tool. This tool is Postgres deployment. So Postgres deployment is an open source project hosted on GitHub. It provides a command line bash script named edb-deployment. This tool allows infrastructure provisioning in public cloud, and it allows also to deploy Postgres instances and its component on the provisioned infrastructure. The resources provisioning relies on Terraform and the Cloud Vendor CLI or SDK, while the deployment part is executed by Ansible and the Edb Postgres collection. The public cloud vendors supported are AWS and Azure and Gcloud. The Edb deployment script will require some components. So the bash shell itself. For AWS and Azure Cloud, their respective CLI must be installed on the system. And for Google Cloud, its SDK must be present on the system. The curl and wget packages must be present. We need Terraform with a version greater or equal to 0.13 and Ansible with a version greater or equal to 2.9. So how to use the Edb deployment script? This script needs 3 arguments for being executed. The context is the first one. It can be AWS server or AWS Postgres or AWS project or Azure server and so on. The second argument is the action to execute. This action will depend on the context. The last argument is the project name. The project name is like a namespace used to store the generated configuration files. The first command line example shows how to provision the required resources in the public cloud. If no configuration file are found, the script will ask for some information about our needs, like what are the cloud credentials, the number of instances, the type of the database engine we want to install, the database engine version, and so on. The second command shows how to deploy and configure Postgres, and the last command shows how to destroy the resources allocated for the project. So now let's take a look at the features we have planned to add in the Edb Postgres Ansible collection and in the Edb deployment script. There are many features we want to push in the EDB Postgres Ansible collection. One major, one major improvement will be to add backup capabilities by adding both barman and PgBouncer support. For the moment, only Red Hat-based Linux distribution are supported, but it will be good to add a Debian-based distribution support. We are thinking about adding an auto-tuning role for Postgres. The goal is to adapt Postgres configuration parameters accordingly to the available hardware resources and the use cases. Cascading streaming replication and logical replication support would be good to have. Logical replication support could lead to online upgrade. We also plan to add Repanger support as an alternative to EFM Postgres for Postgres automatic failover. And we are going to write predefined playbooks for reference architecture deployment, meaning one playbook for a single Postgres node deployment, one playbook for two Postgres nodes deployment in streaming replication, one playbook for three Postgres node deployment in HA, and so on. And about EDB deployment script roadmap. So we are rewriting it in Golang. One of the reasons for this is to have a really portable CLI working on almost all the operating systems. Encrypted volume support is ongoing. And finally, it would be good to have post-deployment tests, ensuring that our deployment is working as expected. And this is the end. So thank you for your attention and feel free to ask a question. Thank you.